Chapter 5, Section 4.2, Part 1 video. In this section, we'll continue looking at exponentials and evaluating decay and growth exponentials and kind of getting a more of a foundation of what exponential functions are. In this first problem, it says find the y-intercept of each exponential function and decide whether the graph is increasing or decreasing. Well, we know if the base is greater than 1, it is a growth, and that would mean that it's increasing. And if the base is between 0 and 1, it is a decay, which means it's decreasing. So before we look at that, we've got to find the y-intercept, and it said enter only the y-coordinate. Well, the y-intercept is when x equals 0. So if I take and go 9.8 times 5.9 raised to 0, then 5.9 raised to 0 all becomes 1 because it's the 0 power rule. Anything raised to 0 power becomes 1. Now that's 9.8 times 1, which is 9.8. Now, let's look at the base. The base is 5.9, which is greater than 1, so it is increasing. Okay, now let's look at the other one. So we go 5.8 times 0.8 raised to 0. We know this right here all becomes 1, so it's 5.8 times 1, right, which is 5.8. Piece of 0 times b raised to t. We said this right here was the initial value. Okay, that initial value is when x equals 0. So that really that initial value is the y-intercept. Okay, but we can, we proved it. The base is 0.8, and that's between 0 and 1. So therefore, this is decreasing. Okay, there's about there's 2 more that you have to do below this one, but that gets you started. All right, using the graphing utility, we're going to graph this on the domain of -1 to 5. So 20 times 0.8, so clear that, 20 times 0.8 raised to the x. Make sure that that's it, from -1 to 5. So I'm going to hit my window, -1 to 5, and I'm going to just graph it. Now, let's go back and look. Give the range of the function on the domain accurate to 100. Put it in as an interval. So I'm going to come back and zoom 0 is what I want. Okay. When I hit zoom 0, that takes my x-axis, which is from -1 to 5, and it gives me all the outputs. So if I look, let's see, if I move this over, bring it here, can help you to see some things. When we do the range, then we're looking at the y values, right? They're y values. And when we put them in intervals, it should be smallest comma largest. So we want to get this point there and that point there. So that's when x is -1 and x is 5. So what we're going to do is go back and look at our table. Okay. Look at our table. So we're going to go second table. Let's go second table setup real quick. Well, I don't guess so. -1, enter, 5, enter. So those are my values. And that is what I'm needing to put. So what's my lowest point? My lowest point is, so to accurate to the hundreds, 10 hundredths, that's 2 decimal places. So that would be 6.55 comma 25. And they both get brackets. Okay. Now let me move this over so you can see highest points at -1 and lowest points at 5. So that 5 is 6.55 and the highest point is 25 on the y. Okay. Hi, in the group of functions, which one have identical graphs? Explain why. Well, you can graph all of these if you want. Okay, but I'm going to show you. It's called the negative power rule, and basically you learn them in the properties of the exponent. Anything raised to negative power, if it's in the numerator, that base gets brought down to the denominator and made a positive. You can use that same principle if you'd like, and I can also rewrite this as 1 over 7 to the x. The reason why I can write that is 1 raised to any power is just itself. And then I can, if it's in the denominator, I can move it up to the numerator like this, 7 to the negative x. Same thing with this one, right? 7x, so it's 7 to the negative x. All three of these match, and D is the only one that's not. So you can graph, and I highly recommend you graphing each one of those so you can kind of see that they are the same graph, okay? And two, it's a decay. My base is 1/7. My base here is 1/7. And my base here is 7, but it's raised to a negative power. So a decay, if the exponent is negative, then and the base is above 1, then you've got a decay. All right, so that's kind of the laws of exponents that makes that all work. Okay, I'm going to work this one. The graph, just come on, tell you about that. Read the initial value. So the y's are going up by 200. So 200, 400, 6, 8. So the initial one is 200. So that's that point right there. Okay. Now, so if I create a table, and that's at 200. Let's look at one. One's here, and it's at 600. And 2 is at 12, 14, 16, 1800. Then we can very quickly see, use the table to calculate the factors. If we take 600 divided by 200, we get a 3. If we take 1800 divided by 600, we get a 3. So our base is 3 here. Because to get to the next point, the output's multiplied by 3. So I can write the equation, and the equation is nothing more than, let me get back here. Equation is nothing more than 200 times 3 raised to the x, right? And that's a multiplying right there. Okay, so that's enough of Chapter 5, Section 4.2, Part 1 video.